In this video, we want to find the limit as n approaches infinity of this fraction. Well, it's not obvious whether this limit is infinity or not. So what I'm going to do is approximate this. Again, a better idea whether the limit exists or not. So what I'm going to do is look at the largest powers of n at both the numerator and denominator. So for this one, n times the sixth root of n, that's the same thing as n times n to the 1 over 6. And then this plus 1 in the long run doesn't really affect my answer. So I'm going to ignore it and just rewrite it like this. Now, which one's bigger, n or the fourth root of n? Well, obviously n is bigger. So that's going to be n. Notice this 3 is the cube root of n cubed minus 1. It is not the exponent of n plus the fourth root of n. Okay, so now I'm going to multiply this by the cube root of n cubed. I'm just going to ignore the minus 1 because, again, for large n values, the minus 1 doesn't really have much of an effect. Okay, so now I'm going to approximate this. Well, which one's bigger? N times n to the 1 over 6 power. Well, this was n to the 7 over 6. Or is n to the 10 thirds bigger? Well, clearly n to the 10 thirds is bigger, so we'll keep that. And then the cube root of n cubed, these will cancel. So you're left with n times n, which is n squared. Now I subtract these and I get n to the 4 thirds. And we expect this to go to infinity as n goes to infinity. So just by doing this little exercise, I see that the limit's probably going to go to infinity. So the idea is, if I find something smaller than this, if that goes to infinity, then this has to go to infinity because it's bigger. Okay. So what I did was I rewrote n times the sixth root of n as n to the 7 over 6 power. And now I wanted to find something that is smaller. Well, how do you find something that's smaller? You want to make the numerator smaller and the denominator bigger. That's how you make the fraction smaller. So in the top, n to the 7 over 6, I eliminated that. So that made my numerator smaller. And then I eliminated the plus 1 here. So that makes my numerator even smaller. Okay. So basically the rule is, like, if you see a plus or a minus, try to eliminate it at the top. Okay, so we see the plus here, eliminate this because eliminating this makes my fraction smaller, and then eliminating this plus 1 makes my root smaller. Okay, so now the numerator is just left as one term. In the denominator, I want to make it bigger. So I say, okay, what's bigger? N or the fourth root of n? Well, obviously, for large values of n, n is bigger. So why don't I change the smaller one into a bigger value? So n is bigger than the fourth root of n, so let's replace the fourth root of n with n. And then if I subtract the minus 1 here, well, I'm making smaller, right? If I subtract something by 1, I'm making it smaller. So by eliminating this one, I'm getting bigger. All right, now I can simplify this. So I have n to the 10 thirds in the numerator, and then I have n plus n. That's 2n. So this thing is 2n. And then the cube root of n cubed is just n. So if I multiply these, I get 2n squared. Now I simplify this. N to the 10 thirds over n squared is just n to the 4 thirds. And I still have the 2 in the denominator. And so if I let n approach infinity, clearly this is going to go to infinity, since the exponent of n is greater than 1. So what we did was we found an expression that was smaller than what I originally started with. That smaller expression went to infinity, so anything bigger will also go to infinity. And so the final answer to this limit as n approaches infinity is infinity.